Oh, yeah. Radicals. Are they radical? It's not really an answer to the question.
That's what the kids say.
They say that? That's not a word, though.
Exactly.
But here's the question: are radicals? Are they lit?
No.
You don't think they're lit? I think they're lit. All right. We are going to simplify some exponents. Okay. Do various problems, different types you can look at. So here, has x to the 0 power. That reduces to 1. Okay. Then we have 3y to the negative 2. The y is the negative 2. We know we cannot have negative exponents. So that means it needs to do the reciprocal and flip to become a positive exponent. Boom! We're already done with our first problem. Okay? Second problem, simplify. So we got this 3u to the 4th power, v to the negative 4. Okay? I'm going to identify that the u has an understood positive 1 exponent. Okay? And we're going to try to combine things that are the like. So this is 3 times 3, which is 9. Combine the exponents on the u's because we're multiplying. So we add exponents when they have the same base. V to the negative 4, v to the negative 3. Combine, same base. We can add the exponents when we multiply. But we can't have a negative exponent in our answer. So it simplifies to 9u to the 5th over v to the 7th. Reciprocal. Negative exponent means we have to do the reciprocal. It flips to the bottom. All right, this next one is exponents raised to a power. Okay, so here we have 3ba to the 4 to the negative 4. It's important you understand that there's a 1 on the 3 and on the b. So when I distribute this exponent here, it becomes 3 to the negative 4, b to the negative 4, and then a to the negative 16. All negative exponents. We have to do the reciprocal. 3 to the 4, b to the 4, a to the 16. 3 to the 4th power is 3 times 3 times 3 times 3, which is 81. And there you have it. Okay? We're going to keep doing some more. So here we have 2x squared, y squared to the 4th power. Put that understood 1 and distribute the exponents. So I get 2 to the 4th power, x to the 8th, y to the 8th. No negative exponents, so we're good there. But 2 to the 4th power becomes 16. Okay? And there we have it, simplified. All positive exponents. Let's keep going. So here we have a problem with some division. So when we divide, we have to do what with the exponents? We have to subtract the exponents. So 2 minus 3 is negative 1. Negative 2 minus 0 is negative 2. Okay? 2 didn't do anything because there was no other number to deal with, so we just left it as 2. But these negative exponents are going to flip to becoming positive. And there you have it, simplified. Okay? Same thing with these over here. So, can't really reduce anything with the 3 and the 2, so we're going to leave it as 3 over 2. But we're going to subtract the other thing. So 2 minus 3 is negative 1. Negative 1 minus a minus, because we're subtracting exponents when they have the same base when we divide. Negative minus a minus is a plus. So it's y to the 2, because negative 1 plus 3 is 2. I get 3 over 2, y squared, and then the x flips to the bottom because it's the reciprocal, because of the negative exponent. And there you have it, simplifying. So those were all exponent property problems without rational exponents. So now we're going to move into simplifying some problems with rational exponents. Okay, so it's going to be a little bit more difficult, but you guys can handle this. Okay, so we have this simplifying problems here. First thing we're going to do is we're going to break it down to its prime factors of 512. Okay, so 512 is, well, I got to do this myself. 512 breaks down into 256 times 2, and then 256 breaks down into 128 times 2. This breaks down into 64 times 2. That's 8 times 8. So that's a total of 2 cubed, which is 2 to the 6, to the 7th, to the 8th, to the 9th. So it's 2 to the 9th, xy to the 7th. We've broken it down to its prime factors. Okay? So now we're going to change this cube root into a rational exponent. Distribute that rational exponent. Reduce / change things into mixed numbers. Okay? So now the stuff with the whole numbers stays outside. And the stuff, so this is the denominator, which means we're taking the cube root of x, y. There we go, and there you have it. Okay, these only had ones. That's why these are the first power here. Okay, let's look at the next one. Simplify here. First we have to do is break this down. So that breaks 112 breaks down into 56 times 2. And that breaks down into 8 times 7. No, 8 breaks down into 2 to the 3rd. So this prime factorization is 2 to the 4th times 7 times a to the 4th times b to the 4th. So it's a square root, which means we're going to change it to the half power. And then we're going to distribute that half. So it becomes 2 to the 4 over 2, 7 to the 1 over 2, 8 to the 4 over 2, b to the 4 over 2. Okay? Reduce our exponent, so it's 2 to the 2, 7 to the 1 half, a to the 2, b to the 2. The stuff with the whole numbers comes on the outside. Since this has a rational exponent, it's going to be turned back into a square root. And there you have it. Just as emphasis, 2 squared is 4. It's really important that you simplify that. I did not do that in the previous problem. In fact, we're going to go back real quick just to rewind. Go back over here. 2 cubed is actually 8y squared cube root of xy. All right. Number 3 is adding, subtracting. Okay? You have to combine coefficients, reduce when these things underneath the radical are the same. Okay? So be -2. Break down its prime factors, which is 2 to the 3 times 3, minus 2, square root of 2 to the 3 times 3, minus 3 times the square root of 3 to the 3 times 2. Because 54 breaks down into 9 times 6, which is, yeah, that's correct. Okay, good. So now we change things to radicals. Okay. Distribute the exponent. Only the stuff in parentheses. Okay? So now we reduce. Okay? And then we change numbers back into whole numbers and rational exponents. Okay, because you have negative 2 and 2, but this is also 2 to the 1/2, which means we're going to do square root of 2 times 3, because the 2 has a 1/2 power and the 3 has a 1/2 power, minus 2 times 2, again, square root of 2 times 3, because 2 to the 1/2 and 3 to the 1/2, minus 3 times 3, square root of 3 times 2, again, 3 to the 1/2, 2 to the 1/2. We get negative 4, square root of 6, minus 4, square root of 6, minus 9 square root of 6, which equals negative 17 square root of 6, because they all had the same number under the radical. Boom! Done. Next! Another one. Ooh, this is the 6th root. Wow. All right. They all have the same number to the radical. Let's just go ahead and combine all the coefficients, make our life easier. So negative 2 plus 3 is 1. 1 minus 1 is, oh, look at that. That was a beauty. That was so nice. All the coefficients combined up to simplify to 0. Awesome. Didn't have to mess with that. Let's do this one. Wow. Got some radicals going on here. Okay. So what we could do here, so there's multiple things we could do. Okay. But when we have an exponent divided by another exponent, and they're both under the radical, couldn't I just subtract here? So then 4 minus 4 is 0, which means that these would reduce to just 3 square root of 2 over the square root of 3. And there you have it. Gotta look for those ways where you can like reduce things. There's certain steps that are different and will work, but there's other steps that will be faster and help you reduce with less steps. Okay? Here is the 4th root. So we're going to have to do some prime factorization here. This one we're actually going to have to break apart. Okay? So I'm going to break these down like so. Okay, and then this becomes 3 because I'm changing it to the rational exponent. Okay, distribute this exponent. Okay, since these have the same exponents, when I subtract them, they'll just reduce. Okay, there's going to be an extra step we're going to have to do here with the 3's. So you have 3, and then 3 to the 3/4. Okay, this is 3 to the 1. Well, 1 minus 3/4 is just what? Isn't it 3 to the 1/4? And then 2 to the 2/4, which then would reduce to the 4th root. Look at this. This is really important. 4th root because it's the denominator. The numerator on the 3 is 1. The numerator on the 2 is 2. We can multiply these together to get the 4th root of 3 times 4, aka the 4th root of 12. Okay? Next one. Ooh, 6th root. Okay, since they have the same root, we could change it. Oh, well, let's factor that down real quick. Okay, so 6, 3x squared times 6th root, 2 squared, x to the 5th. Change it all to a rational exponent. Distribute the exponents. It's 3 to the 1 6. Why? Because there's a 1 on that 3. X to the 2 over 6. 2 to the 2 over 6. X to the 5 over 6. Okay? We cannot combine the exponents on here because these are not the same bases, but the x's have the same basis, so I can combine the coefficients there. There's a reason why I'm not reducing this 2 over 6. It's really important you pay attention to that. Okay? Because ultimately, I want to have all the exponents have the same denominator. This becomes x to the 7 over 6, which then all reduces to 3 to the 1 over 6, 2 to the 2 over 6, x to the 1 and 1 over 6, which then becomes the 6th root of 3 times 2 squared times x, because it's the 6th root, and then I used all the numerators, 1, 1, 1, 2, 2, 1, 1. But there's also this whole number, which means there needs to be an x out front. And this will eventually simplify down to the last part, which is x 6th root of 12x. And that's the simplest form. All right, let's keep going. So we're going to have to change some rational exponents here. I'm going to go ahead and break this down to the prime factor and the rational exponent. Distribute the rational exponents. It becomes 5 to the 1/2, x to the 3/2, times 3 times 2 to the 2 over 2, times 5 to the 1/2, times x to the 2 over 2. Combine our exponents. So I get 3 to the first times 2 to the 2 over 2, times 5 to the 2 over 2, times x to the 5 over 2. Reduce exponents and change to mixed numbers when I can. So it's 3 times 2 times 5 times x to the 2 and 1/2. So it becomes 630 x squared, because x squared is the whole number. This 1/2 means 2 is the square root. 1, so it's x to the 1. And there you have it. Wow, did lots of simplifying radicals, some operations with exponents. Now let's do a couple of those exponent equations, okay? So here, 4 is, I think, what we need to find is our common base, okay? Well, 4 times 4 is 16, times 4 is 64. So I can just change this to 4 to the 3rd power. So when the bases are the same, I can set the exponents equal to each other. Solve for x. X equals 3 over 2. Over here, similarly, you really want to get those bases the same, okay? So pay attention to this. This is really important, okay? So I can do 6 times 6 times 6, okay? Which, okay, so we got to break this down. Even I got to do this. You know, it happens. Sometimes we just got to break it down. So it's 108 times 2. That breaks down to 54 times 2. Okay, and then that breaks down to 6 and 9. So that means, ooh, this is a little more complicated. All right, so 216 is actually 6 to the 3rd power, okay, to the 2n, equals 1 over 6 to the 3n. All right, we got to multiply those exponents, becomes 6 to the 6n equals 6 to the negative 1, 3n. Why? Because I do the reciprocal, change the sign on the exponent. The exponent here was 1. When I flip it, it becomes negative 1. Multiply those exponents, I get 6 to the 6n equals 6 to the negative 3n. Set the exponents equal to each other, okay? And now we're going to solve for n. Add 3n, 9n equals 0. Divide both sides by 9. N equals 0. And there you have it. One more problem to finish it off. We've been really going through lots of problems, but I felt like that was really important to get these procedures out there for you to see some problems visually, to kind of help you out, to see the steps and how to think about problems and listen to me talk about it as I go through it. Last problem. All right. Wait a minute. 1. How? What? I don't understand. All right. So 1. What I got to do here is make the exponent to the 0 power, because anything the 0 power is 1. So now I can just set these exponents equal to each other. Solve for x. X equals 0.